Hello friends, in this class we shall learn how to find out and calculate the median of a given data set. Okay, what is median? Median is the middlemost observation in a given data. Median is the middlemost observation in a given data. So suppose if we are having a list of data, the one which occurs in the middle, obviously after arrangement of the data in either ascending or descending order, will give you the value of the median. Okay, so we shall now discuss how to find out the median for individual data, group data in case of discrete series and group data in case of continuous series. Okay, so let's get started. First, let us learn how to find out the median in case of individual data. Okay, so median for individual data. Okay, how to calculate median for individual data? So it depends upon whether the number of observations are even or odd. So let us consider the example. If number of observations is odd, okay, is odd, that is n is odd. So let me take an example where n is odd. So where n is odd, let us consider x, the set of all observations, as say 5, 8, 6, 3, 10, 9 and 1. Okay, so this is the set of 1, 2, 3, 4, 5, 6, 7 observations. So in this case n is odd. Okay, in this case we have that n is odd. Okay, n equal to 7. What is this? This is odd. Okay, so now what is the first step? First step is to arrange the data. The first thing is arranging the data. So how to arrange? So x becomes, so let me arrange them in proper order. This is 1 first, smallest, then 3, then we have 5, then we have 6, then 8, then 9 and 10. Okay, what is this? This is arrangement of data, arranging data. This is arranged meant. Now median is defined as the middlemost observation. What is median? Median is the middlemost value. Okay, so let us see which one is the middlemost value. So let us see. Okay, here see there are 3 observations to the left of 6 and 3 observations to the right of 6. So we can clearly say that 6 is the median. This is the median value. Median value. Okay, so now mathematically we have to write down a formula to find out the median value. If n is odd, if n is odd, the median will be, median denoted by ME will be equal to, see, n equal to 7, 7 plus 1 is 8 and 8 by 2 is 4 and 6 is the 4th observation. Now let us see, this is the first observation, this is the first position, this is the second position, the third position, this is the 4th position, 5th position, 6th position and 7th position. Okay, median is a kind of positional average. What kind of average is it? It is positional average. Median is a positional average. Median is a kind of positional average. Okay, we know this. Now let us consider the formula. Okay, so if n is odd, then we can have this formula, n plus 1 by 2th value. Okay, n plus 1 by 2th value. This is the formula to find out median in case of odd number of observations. So here in this case n equal to 7, what is it? Odd. So therefore median equal to n plus 1, n equal to 7. So 7 plus 1 divided by 2 value. Okay, so 7 plus 1 is 8, 8 by 2 is equal to fourth value, which is the fourth value is 6. So this 6 is our median value, equal to 6. Okay, hope you have understood this. Now we shall move on to a case where n is even. Okay, so where n is even. Now if n is even, what happens? If n is even, let us consider an example for n equal to even case. If n is even case, okay, so let us consider the example as, say, x equal to 1, 14, 20, 15, 17 and 24. 1, 2, 3, 4, 5, 6. Okay, so there are 6 observations where 6 is even. Okay, so now first thing is we need to arrange the data. Arrange the data as 1 first, then comes 14, then 15, then 17, then 20 and then 24. We have already arranged them. Now see, we do not have a central value. Okay, we do not have the central value, so we take the middlemost two observations which come at the center, and their average will be taken as the median. Okay, so in this case again let us see what are the position values. This is the first position, this is the second position, this is the third position, this is the fourth position, this is the fifth one, and this is the sixth position. Okay, these are the different positions. Now the median is somewhere between third and the fourth observations. Okay, median is somewhere between the third and the fourth observations. Therefore the median when n is even will be given as, see, 6 by 2 is 3, so you can come to this position by dividing n by 2. Okay, so therefore it is n by 2th value plus the next value. How to get the next value? It is n by 2 plus 1th value divided by 2. That is the average of the simple average of the third and the fourth observation. Okay, so in this case the median ME will be equal to the third value plus the fourth value. What is n? N is equal to 6. N is equal to 6. Here n equal to 6. So therefore when n equal to 6, it is equal to 6 by 2 value plus the next value, or 6 by 2 plus 1th value divided by 2. So we get 6 by 2 is equal to third value plus the next value, that is fourth value, divided by 2. What is the third value? Third value is 15. So we have 15 plus the next value is 17 divided by 2. So you get 15 plus 17 is 32 divided by 2, and that is equal to 16. Okay, clearly 16 lies between 15 and 17. Okay, so 16 is our median in this case. So let us now just discuss what are the different formulas for finding mean in case of individual data. Okay, so in individual data, if n is odd, the median will be obtained by n plus 1th value. Median will be obtained by n plus 1 by 2th value. Okay, so therefore if n is odd, the median will be equal to n plus 1 by 2th value, and if n is even, the median will be given by n by 2th value plus n by 2 plus 1th value divided by 2. Okay, so this is n by 2th value plus the next value, okay, divided by 2. So here in this case we have 16. So note down these formulas and we shall move on to the next case, how to find out the median of a grouped data in case of discrete series. Discrete means separated values, not continuous. Okay, so median of of grouped discrete data. Okay, in case of discrete data, let us find out the median. Okay, let us consider a grouped data. Grouped data means it has frequency. It has frequency. Let us consider the example as, say, suppose we have x and the corresponding frequency is f. Okay, so we have, say, 2, 4, 5, 8 and 10, and the corresponding frequencies are 1, 3, 5, then I'll take 2 and 1. Okay, this is 10. Now how many observations are there? Here we do not consider whether it is even or odd. We directly consider the total number of observations. So here it is, say, 3 plus 2 is equal to 5, 10, 11 and 1 is 12. Okay, so this is 12. Okay, for this first thing is we need to arrange them, and if they are already arranged, then we need to find out the cumulative frequency. Cumulative frequency, less than type cumulative frequency. We need to find out the less than type cumulative frequency. Less than type cumulative frequency. Now it is very simple how to find out the cumulative frequency. This is, say, 2 and this is the first frequency is 1. Okay, then 3 plus 1 is equal to 4, 4 plus 5 equal to 9, and 9, 10, 11 and then 1 is 12. We can observe that this both of them are same. This is n equal to sigma fi and that is equal to 12. Okay. Now the formula to find out the median is median ME will be equal to n plus 1 by 2th value. Okay, so this is the formula to find out the median. Now let us find out this. N is equal to 12, and so n is equal to 12 here. In this case, n equal to 12. So what is n plus 1 by 2? So therefore median equal to, or 12 plus 1 by 2 value. Okay, so therefore we have 13 by 2th value, and that is nothing else but 6.5th value. But here we don't have the 6.5th value. It is either the 6th observation or the 7th observation. Means it is the lying exactly in the middle of the 6th and the 7th observation. Now the 6th and the 7th observation, how to find out the 6th or the 7th observation? See clearly 6.5. Take this 6.5. Where does 6.5 lie? Where does 6.5 lie? In the cumulative frequency section. Try to find out slightly higher value or a value which is equal to this value. Okay, so it is 9. 9 is a number, or 6.5th value will lie in this class or this group. Okay, we know that 5th observation, 6th observation, 7th observation, 8th observation and the 9th observation are all 5s. That is the 6th and the 7th observations will also be 5. Okay, so therefore we will take this, the value of x, corresponding to a cumulative frequency which is slightly higher or equal to this value will be called the median. Okay, so therefore the median will be 6.5th value will be 5. Okay, so therefore this is the median. Hope you have understood this. We shall take one more example to understand this better. Okay, so let us take one more example. You can note this down. Consider another series x and f. Okay, I will be taking arranged data. So in case if it is not arranged, you need to arrange them. So the values of x are, let me take 2, 3, 7, 8, 9 and say 11. And here I will take 7, then we have 4, then 2, 3, 5 and 3. Okay, so therefore total number of observations will be 24. Okay, how to find out the median? Median is the n plus 1 by 2th value. Median, see this is n. Okay, median is, what kind of observation is this? This is discrete but grouped. Okay, so median ME will be equal to n plus 1 by 2th value. Okay, so how to locate this value? We need to find out the cumulative frequency CF. Okay, so this is 7 plus 4 is 11, then 12, 13, 14, 15, 16 plus 5 is 21, and then we have 24. Okay, this is less than type CF. We need to check that these two values should be same. Okay, these two values should be same. Now what are we supposed to do? We need to find out what is n. N is 24, so this is 24 plus 1 by 2th value. Okay, so that is equal to 25 by 2. This is 25 by 2th value. Which is the 20? What is 25 by 2? 25 by 2 is 12.5. So that is equal to 12.5th value. What is 12.5th value? Where is 12.5? A number which is slightly higher than 12.5. That is 13. So we will take this group. This is where it lies. Okay, 12.5th value lies here. So we have 7 as the median. Okay, so therefore, and that is equal to 7. Now I think you are clear with this topic. Okay, now we shall move on to the next topic, continuous frequency distribution. Now let us discuss how to find out the median of a given data for grouped frequency distribution. Okay, the first step is to prepare the less than type cumulative frequency distribution. Second is to find the median class. How to find out the median class? It is the class in which the n by 2th observation lies. Okay, the class which contains the n by 2th value will be called the median class. Then using the following formula, that is m is equal to L plus n by 2 minus CF by F into C, where you know what is n by 2? N by 2 is the n divided by 2. N is total number of observations. Now C is the class length and F is the frequency corresponding to the median class or frequency of the median class, and CF is the cumulative frequency preceding median class. Okay, cumulative frequency of the class preceding the median class. Okay, so that's it. Now let's get on to the problems. Okay, example for continuous series. What we have is, let us consider CI or class intervals as 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, so let me take frequencies Fi as 3, 2, 4, 1. What is the total? 3 plus 2, 5, and this is 5, so total is 10. So the first step says that find the cumulative frequency. Find the cumulative frequency. What is the first step? It is already arranged, so therefore first we need to prepare the cumulative frequency distribution. So how to find out the less than type cumulative frequency? It is 3, so 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 1 is 10. These two should be equal. This is our n equal to 10. Okay, what is now let us find out n by 2. What is n by 2? N by 2 is 10 by 2. 10 by 2 is equal to 5. So where does 5 lie? Where does 5 lie? 5 n by 2 appears to be here. Okay, either here or it should be greater than this value. It is this line. So this is the median class. This is the median class. This is the median class. Okay, so therefore now this is the lower boundary point of the median class, or this is the upper limit of the median class. Okay, so therefore this is L1, this is L2. Okay, and this is CF. This value is CF and this is F. Okay, we can take this as L also in case of normal formula. So therefore the formula is n by 2 CF median equal to median ME is equal to L plus n by 2 minus, or n by 2 minus CF divided by F into C. Okay, what is L? L is a lower boundary point, that is 10 plus n by 2 is 5 plus minus CF cumulative frequency is 3 divided by F is equal to 2 into C. What is C? C is 10. Okay, so this is 10 plus 5 minus 3 is again 2 by 2 into 10, so we get 10 plus 10, that is 20 appears to be the median.